Oh boy, things are heating up here because now we're going to find the derivative by using implicit differentiation. And can you see here immediately that we're going to have to use the QR, the quotient rule? Remember, if we call this f and this g, because we have y's now, I'm hesitant to call them functions, but it's going to be the derivative of the numerator, 7, times the denominator, minus the numerator, 7x, times the derivative of the denominator, dy dx, all over the denominator squared, is equal to, by implicit means, this would be 16x minus 0. So now we've got to get dy dx all alone. Remember, from here down, once we've set this up, this is just testing your algebra skills. Multiply both sides by the denominator, we get 7y minus 7x dy dx is equal to, if I multiply both sides by y squared, I get 16xy squared. This 7y is floating, so I'm going to say negative 7x dy dx. If I subtract 7y from both sides, I get 16xy squared minus 7y. Now, I could divide both sides by 7x, but I prefer to multiply both sides by the reciprocal. So just hear me out. If I multiply this by 1 over negative 7x, and I multiply this side by 1 over negative 7x, in my experience, students have a better time dealing with getting the correct answer. If I distribute this to both, I get 16xy squared over negative 7x. Negative times negative is positive, and I'm left with 7y over negative times negative is positive, 7y over 7x. As we pick up where we left off, I ask, can these be simplified? Again, this is all just algebra. Within each fraction, I've got two terms. So within each term, I can simplify x cancels with x, and I'm left with negative 16 over 7y squared. Remember, if there's just one negative, I can bring it out front. And the 7's cancel. So this would be our most simplified answer to finding that derivative.